Good morning, my YouTube viewers. Crystal here. I'm here this morning because I wanted to give you the solution to the Kaggle's digit recognizer competition. I was really surprised that I got as high of a score as I did. I thought it was going to be really low, but it turned out to be the highest score I've ever made on Kaggle, except for the fact I'm not sure about the house price index because they scored that another way. You can see that this morning I submitted my submission and I got almost an 84%, which is not bad for the first attempt. What I wanted to show you was I wanted to show you my submissions, and I thought it was going to be a really low score, but I just wanted to get on the leaderboard, and I didn't care what the score was, just so long as I got on the leaderboard. Well, the first time it was in error because I didn't have an image ID on the test file. They didn't give you an image ID on the test file, so I put an image ID column in, and the second time it went in error because I created an image ID by duplicating the index or by making the index the image ID column, but I had to add a 1 to that because the image ID started with a 1 and an index started with a 0, and so that's why it failed the second time. So the third time I submitted it, it passed it almost an 84%, which I think is quite good for a first attempt. So now what I want to do is I want to do a code review of the solution. So if we go into our netbooks and we look at my work is called Recognize the Digit. You see it was successful. So if you know that this is a solution that's going to work. So what I'm going to do is I'm going to share my notebook. So if you want to create a copy of the notebook, that you're more than welcome to, because it will get you on the leaderboard. Now, what I did was, because I've never done any identify the numbers or identify the digits, I had to use a YouTube video to find out how to do it. And I was quite surprised that it was as simple as it was. The only problem is that the training file and the test file are very memory intensive, which means that I cannot put them on GitHub. And I didn't want to do it on Google Colab because I didn't want to use up all the memory in my Gmail account, because you only get like 15 gigs free, and then after that you have to pay for it. So I don't want to use all my memory on files like text files and train files. So I just did this on So I just did this on the Kaggle Jupyter notebook. So the files, the train file, the test file, and the submission file are kept at Kaggle, and they're not kept on my computer, because that's something that I don't want to do. I don't want to use up all of my memory, because when you use up your 15 gigs, then you have to buy more memory, and I don't really want to do that. Eventually, what I'll have to do is probably move some of my files over to another Gmail account or something like that, but that's not really something that I'm looking forward to doing. It's just lots of work. So first, after I loaded up the libraries, which you will see it's not that many libraries, just NumPy, Pandas, Matplotlib, and Decision Tree Classifier, and we were able to do all this with just those 4 libraries. Then we loaded up the files. And the next thing we did was we read the files. So you can see the train file here. The train file has a label, but it doesn't have an image ID. The test file does not have a label. and it doesn't have an image ID either. But you'll look at the sample submission. The sample submission is looking for an image ID, and you'll notice that your index is 0, but the image ID is 1. And I will show you how to get around that at the end of this video. So you have to watch all the way to the very end to get the answer to that question. So, and then what we did was we set up our model, which was a decision tree classifier. And then what we did was we set up our training files. So DT means train.values, DT is train.values, S type int64, and train size is int length DT times .5. Then we set up our training data set links, and I had problems using this because what I had to do was I had to add ILOC to the formulas, otherwise it wouldn't work. So that's what you do to get the formula to work. You type up ILOC. In addition, the originator of this algorithm, he typed 2100, but whenever I was troubleshooting, I was looking at another computer program that I had made, and they had set up something called a train size. So I decided to just go ahead and use the train size rather than using 2100. And 21000 is half of 48000. So what you were doing is you were setting it up so half of the file was your training file and half of your file was your testing file. And that's what they were setting the situation up as. So we fit our model. So CLF fit X train label. So you notice here we set up train label here and X train. And then if you wanted an image, you can use this text right here to actually get an image. And that was the original program. Well, all this guy did was just plot an image, and he did plot an image, and it does work. So, well, I had to get it to work, so I had to use iLock. I had to put iLock in this line of code right here to get it to work, and then I had to use reshape because he hadn't done it didn't work unless you did reshape. But it does work. If you feel really brave and you want to try it, I can let you know that I tried it and it did work. But I decided that for the purpose of this competition, I was just going to make those all comments and not use it. So now we set up our prediction as clx.predictxtest. And then I wanted to see what P looked like. I wanted to see the shape of P, which is 21,000, and that's half of the size of the train file, which was 42,000. And then so what we did here was you wanted to check the accuracy, and somehow or other, the guy that wrote the original program, he got an accuracy in the high 70s, and when I did it, I only got an accuracy of like 9, but I thought, well, I want to do this anyway. I said, I want to get on the leaderboard anyway. Even if I score 9%, I want to get on the leaderboard because I can work on it after I've gotten on the leaderboard. So everything past this point is stuff that I've done, stuff that I had to figure out on my own. The guy that wrote the original program, he stopped writing at that point, and everything else is my work. So I set up TT equals test.values, TT equals test.sType int 64, test size equal int len TT. So whereas on the training file, they set the training file to be half of the training file. So it was 42,000 and half of that was 21,000. On the test size here, we want the test size to be 100%. So I just said len TT. And then so what we did was we test our data links. Xtest1 equals test iloc test size 1, but I don't think I even used that. We'll look and see. And then I set up my prediction, P1 equals CLF predict test. So we just put the whole test file in there, and I wanted to see what P1 looked like, and you see it's an array. I wanted to see the shape of P1. It was 28,000, and that was the length of the training file. So we had to set up a submission. So the submission equals PD data frame. The image ID is test.index plus 1. So you have to put the plus 1 in there, because if you don't put the plus 1 in there, the first number is going to be 0. And then the label is P1. So we created our submission CSV file with that, and I wanted to see the submission. So you'll see the image ID starts from 1 and then goes all the way to 28,000. And if you submit that, it will work and it will get you on the leaderboard. But I'm not going to submit it because, number one, I submitted it the first time, and number two, I believe we only get like 10 submissions a day, and I don't want to submit something when I don't need to submit something, because that's just going to eat into my 10 submissions that I get a day. I was really surprised at how this algorithm wasn't really that difficult, because this is the first time I've done recognize the digits. And obviously you get really scared the first time you do something, but I was surprised that you only needed 4 libraries, and I was surprised that you didn't need that much code. It really didn't take a great deal of code. It was just CLF equals decision tree classifier, and then you fit the model, and then you predict it. And so that was quite a basic program to get you a very high output. The author said that you could practice with nearest neighbor, which I'm going to experiment with nearest neighbor, and I'm also going to experiment with XGBoost to see if I can get my score higher. But I think 83,567 is a pretty respectable score as a first attempt, and I'm quite chuffed with myself. But if you like this video, please like, subscribe, and share. You can let me know what you think about the video and what you think about the algorithm. And if you like the work I do, I've got my email address for my PayPal account in the comments down below. And the reason why is because I don't have enough subscribers to get monetized, so I have to ask for donations. But donations will help with my living expenses, and they'll be very greatly appreciated. Thank you so much for watching my video till the very end, and I look forward to making another one for you.